Welcome again to my YouTube channel. Today I want us to share a simple concept in matrix, basically determining the determinant of a matrix and also the inverse. And I'm going to vary my method so that at least you can have an option when it comes to determining the determinant of a matrix and also the inverse of a matrix. Now, when given a matrix such as 2, 3, 4, and 5, and you are required to get the determinant of this matrix. So the determinant of this matrix is basically given by the multiplication of the major diagonal, which is 2 multiplied by 5, and then we subtract the product of the minor diagonal, which is 3 multiplied by 4. So this gives us 10, and this gives us 12. So the determinant of this matrix is basically negative 2. Basically negative 2. Now, after determining the determinant, we can move further and find the inverse of this matrix. Now, the inverse of a matrix is basically that matrix when pre-multiplied with a given matrix gives you identity matrix, such that if you are given matrix A, its inverse will be A inverse, such that A inverse pre-multiplied by matrix A always gives us the identity matrix. Now, after getting our determinant, to get the inverse of a matrix, we will say 1 over the determinant, and then we interchange these values, that is 5 and 2, in the major diagonal, and then we multiply the minor diagonal values by negative 1, so that we have negative 4 there and negative 3 there. Now remember, 1 over determinant is basically 1 over negative 2, 1 over negative 2 into our matrix is now 5, negative 3, and then negative 4 and 2. And we're going to multiply each part with negative a half. So we multiply negative a half by 5 gives us negative 5 over 2. When we multiply negative 4 by negative a half gives us 4 over 2. When we multiply negative a half by negative 3 gives us positive 3 over 2. And when we multiply negative a half by 2 gives us negative 2 over 2. And we can simplify this part and say this is negative 5 over 2, this is 2, this is 3 over 2, and this is negative 1. Now, this matrix is what we are calling the inverse of the given matrix here, such that when you pre-multiply this matrix by the given matrix, we always get the identity matrix. That's one of the methods that can be used. Another method that can be used to determine the inverse of a matrix, we can do it as follows. I'm going to use the same matrix, to try and find the inverse of that matrix. Remember, the matrix was 2, 3, 4, and 5. So what I'm going to do, I'm going to get the inverse matrix and say let the inverse matrix be A, B, C, and D as follows. And then I pre-multiply these. Pre-multiplying means it comes before the given matrix. 2, 3, 4 and 5. And this should always give us the identity matrix, which is 1 0 0 1. Now remember, when you're multiplying matrices, always remember to follow the rule. You're multiplying rows versus columns as usual. So we are going to multiply A by 2 so that you have 2A. And then we add B multiplied by 3, you get 3B. And this should be equal to 1. Should be equal to 1. And then we also have the first row multiplied by the second column, which gives us A times 4 gives us 4A, plus 5 times B gives us 5B, and this should always be equal to 0. Now, we can also multiply the other part, so that you have C multiplied by 2, you get 2C, and then D multiplied by 3, you get 3D, and this should be always equal to 0. And then C multiplied by 4, you get 4C, plus D multiplied by 5 gives us 5D, and this should always be equal to 1. Now remember, these are simultaneous linear equations and can be solved together or simultaneously. So I want to eliminate A here. That means I'll multiply here by the coefficient of the second part, and I'll multiply here by the coefficient of the first part there. And I'm going to multiply everything with those coefficients. So what I have here, 4 multiplied by 2 you get 8A, plus 4 multiplied by 3 gives us 12B, and this should be equal to 4 times 1, should be equal to 4. 2 multiplied by 4 gives us 8A, plus 2 multiplied by 5 gives us 10B, and lastly 2 multiplied by 0 gives us a 0. Now we want to get a 0 here, so we put here negative, so that we have 12 minus 10 gives us 2B, should be equals to 4 minus 0, which is 4. And from here you can see that your B is equal to 2. Now after getting B, you can determine your A by picking one of these equations and replacing your B with 2 as follows. Place your B with 2 as follows. I'm going to pick the first equation here, where I'll say 2A plus 3B is equals to 1. But remember, my B is 2, so I'm going to have 2A plus 3. Instead of B, I replace that with 2 so that I can get 1. So this is 2A plus 6 is equals to 1, and 2A is equals to 1. We now subtract 6 from that side, so that 2A is equals to negative 5, and your A is negative 5 over 2 when you divide all through by 2. We have already worked out the first two linear equations simultaneously. Let's do that to the second equation, so that we have 2C plus 3D is equals to 0, and 4C plus 5D is equals to 1. Again, I want to eliminate D here, so I'm going to multiply the first equation with the coefficient of the second equation, and I multiply the second equation with the coefficient of the first equation as such, so that now 5 multiplied by everything here gives us 10C plus 5D, 3D times 5 you get 15D, which is equals to 0 times 5 gives us 0, and 4C multiplied by 3 gives us 12C, plus 5D multiplied by 3 gives us 15D, and this should be equal to 1 times 3, which is 3. I want to eliminate D, so I put there negative. So this gives us negative 2C is equal to negative 3. 0 minus 3 is actually negative 3. So when I divide this by negative 2, I get my C as 3 over 2. Now after getting C, I can still get my D as follows. I will pick my equation as follows. Let me erase here so that I can get space to work it out. I pick the first equation, 2C plus 3d gives us a 0, but my c is 3 over 2, so I'll have 2 into 3 over 2 plus 3d gives us a 0. Remember, this one multiplied gives us 3. This is 3 plus 3d is equals to 0, and 3d is equals to negative 3. So divide through by 3 to get d, and our d is equal to negative 1. Now we have already determined all the values, and we have already seen that remember our matrix was A, B, C, and D, and those values have already been determined, and the matrix therefore becomes your A is negative 5 over 2, your B is actually 2, your C is 3 over 2, and your D is negative 1. Now, you can remember this is exactly the matrix that we had found, and this becomes the inverse of the matrix that we started with, that is 2, 3, 4, 5. And this is the matrix when multiplied with the initial matrix gives us the identity matrix. Now, this is a very simple concept in multiplication of matrices, where you require to determine the determinant and also to go ahead and find the inverse of a matrix. Kindly remember to subscribe so that we can share this information, and also remember to share with your friends. Leave a comment at the comment section, and I'll be glad to read the same and share the concepts as requested.